Okay, so we're going to check out the observatory. Okay, it's a little dark in here, so put on a light, and then I will open the roof. So this is currently the telescopes that I am using. This is Paramount ME2 equatorial mount. It's robotic, very, very accurate mount. Tracks superbly, even without an auto guider. And very, very happy with this mount. Probably will not get a better one in my lifetime. And we'll take a look at some of the telescopes. Currently, I am using for imaging this little one. This is a Stellar View 70. It's a 70 millimeter telescope, and it's got what's called a field flattener on it, which is this piece. And this is the actual camera that is used to take images. It cannot be used without a computer. Basically, you've got to have a computer to control it. And it has no lens. It uses the telescope as its lens. So currently, that's the one I'm using, and it's pretty nice. It's got a fine focuser, dual speed, and then you can rotate. If I can find the control, you can also rotate this way to orient your subject. So very happy with that scope. It's very good for wide field, large objects. The other telescope here, the orange one, is a Takahashi. This currently doesn't have a camera on it, but it would go right in here. The camera is currently out for service. This is a very, very specialized telescope. Basically, it's a 500 millimeter f2.8 optical system, so it's extremely fast optically for astronomy. And if we pop the cover off, if you look down inside there, you can see a mirror. And that is basically it's 190 millimeter, a little over 7 inches, I believe. This guy here, 70 millimeter. Very small by today's standards, but it's a very nice scope. This isn't particularly big, but for astronomy imaging, you don't need a giant telescope. Oftentimes, the optical conditions in the sky, the seeing conditions, will not support imaging with a large telescope. So something like this works well. This is a 500 millimeter focal length. And this is a remote control focuser that I can use to focus the telescope from in the house or over here at the workstation. So everything is controlled by a computer. So I'll go ahead and fire that up. I use this computer to get things initially set up, but then I control everything from in the house later on at night. And I'm going to fire up the mount. There's a switch under here. Turn that on. This computer sits outside all year long, so it's got a solid state hard drive, got some cobwebs. So what we're going to do is the program, the software that you use to control this mount is called the Sky. And then the first thing we have to do is connect to the telescope. So we go start up, we go connect telescope. Then it's going to say the mount is not home, so we have to go ahead and do that routine. What that's going to do is it's going to move the telescope to a specific area in the sky. So it's kind of a startup sequence. We're going to go ahead and do that now. And you'll see the telescope. It's going ahead and going to go find that home position. So currently, that's where the telescope's pointing. Now, it's daytime, so there aren't really any stars out, but I can always point this to a star. If I click on it and then say slew, and I ask you, are you sure you want to do that? I'm going to say yes. And then you can see that icon is moving, and so is the telescope. Now I have it set to move fairly slow, just in case there's any issues. So the telescope's going to go ahead and position itself on Vega. And if it was nighttime, we could do a quick image with the camera, and the star would be centered in the camera's field. And then once this telescope finds the object, it will automatically track it until you tell it to do something else. So the camera is very, very sensitive. It can record naked eye stars in small fraction of a second. And it can, with this telescope, I can get down to probably about 18th or 19th magnitude, which is many, many thousands of times fainter than what the human eye can see. So in the observatory, there are a lot of, I have my maps and things if I want to do a quick look at a few things. I've got loads of adapters and things. It's kind of a mess in here because I've been doing work. Then I have a wall here with my old stuff from when I was much younger into astronomy. Some of these things were in my room 40 years ago. Some of my early favorite sky and telescope covers and how and why books I had when I was like less than 10 years old. Another map I had in my room. Power supply is for various things. There's a control for the digital focuser. Got an Ethernet switch because a lot of things here are controlled by Ethernet. Then I have music, different things. These are focusing masks to help me get a precise focus. More adapters, filters, things like that. And over here, just more stuff associated with astronomy. This winch here I can use if the roof is loaded with snow. It's pretty heavy, it's hard to move, so I can use the winch. And just a few other things in here to round out the observatory. Power panel. So it's pretty much pointing up at Vega, but there's nothing to see right now because it's way too bright. Down here on the pier, there's various power adapters for various telescopes and cameras. You can't see it, but underneath here there is about 7,000 pounds of concrete that keeps this completely stable. And the observatory is independent of the pier, so you can jump around in the building, and even if the building shakes, the telescope will remain solid. So that is a very quick tour of the observatory in the daytime. Heading back to the observatory, it's now dark. Okay, what we're going to do here is this camera, it's kind of dark in here, currently has a hydrogen alpha filter on it, which is good for certain nebula, but it's not good for stars for demonstrating, so I'm going to remove that. It unscrews from the camera, so we'll take that, set that aside. This piece here is what's called a field flattener, and because many telescopes don't have a perfectly flat focal plane, this is used to correct that, and such that the stars will not look like check marks away from the center of the field. So we'll go ahead and we'll put the camera back on the telescope. Okay, normally I wouldn't have all these lights on, but since we're trying to do a little bit of a video here, we have to have some lights on. One of the things I got to do is I got to take the cover. Oh, it is off. I must have left it off. Telescope. Camera's on. Bring up the sky program. Start up the telescope. And once again, telescope's going to find that home position. It knows the time of day. It knows where it is on Earth. Okay, so here's the program. You can see the moon over here. This circle is basically the limits of what I can look at. I can't see everything in that circle, but I can see a lot of it. So just to do a focus demonstration, I will go to Altair. So I'm going to slew the telescope to that point. And that icon will move up to the star. Okay, now put that program down for a minute. We'll bring up Maxim DL. And camera control window. Connect the camera. We'll go to expose. We're going to go to focus. And I got it set. I'm going to go for a 1 second image. Set that in there. And I'm going to tell it to start. So what it's going to do is it's going to take a 1 second image of the star. And then it's also going to take what's called a dark frame. So if I shrink this down, you can see there's the picture. But I want to get a focus on this star. I can tell it's not focused. So we are going to basically go to continuous, and I've put a box around that because I'm only interested in that star for the purpose of focus. So we're going to bring this up. Now before we're not going to try to focus this just by eye. We're going to use this mask. This is a batten-off mask. It will greatly help the focus ability of the star. Because what we're going to do is unlock the focus knob, and this is a very fine focuser. You've got fine adjustment and wide adjustment. The goal is to get that star. I want to get these crosses basically so that one of them's right smack in. I'm going to rotate this a little more. I like it straight up and down. There we go. And what we're trying to do is make sure that that center line is exactly centered in between the other two. Once we have achieved that, the focus will be better than you can probably do by eye. And we're ready to go into the house right now. We'll control everything remotely from the house. So I'll go ahead and stop this now. I'm going to shut the monitor off, kill these lights. There's not going to be anybody out. I'll leave the red one out, but there's really going to be nobody out here. We'll control everything remotely. It's not so bad in the summertime. Summertime you get bugs. Wintertime it's freezing cold. So that's what it looks like. We're going to go into the house. All right, so this here is what I call my mission control. I have many screens, so I have entertainment while I'm doing stuff, so this thing blacks out. And what I'm going to do, we'll get rid of this. We are going to do a VNC, which basically means we're going to remotely log into the computer that's out in the observatory. So we'll go ahead and do that. So what this screen shows is exactly what we saw out in the observatory. So I can be in here in the house in the warmth, even though it's freezing outside in the wintertime, and control everything. So I'm going to go back to the Sky program, and what I'll do is we're going to search for M39 Cluster. I'll just type that in. It's going to say find, and you can see that it shows it up there. So what I'm going to do is I'm going to tell the telescope to go to that. And you'll see this icon is going to make its way up there. And that's basically the telescope is moving. And we'll confirm that later. Okay, the telescope is now at its location. So what I'll do is I'll zoom in. And you can see I can zoom in more. And there's the North American Nebula, which I have imaged before. And here is cluster M39. So now that that's in the telescope, we're going to minimize that program. Then we'll come over here to Maxim. And we're going to do find DSO, which is basically find deep space object. So we'll do a quick 10-second exposure on that, and we will see what it looks like. So you can see it's going to, the camera is now taking the exposure out in the observatory, and then it downloads it. So what do we got? Of course, the moon is out there, so it's going to interfere with a lot of stuff. But if you look here, this is the cluster. So what I'm going to do is I'll do the same thing, only I'll do a much longer exposure. Let's do 2 minutes, 120 seconds. Okay, so this image is getting close to being ready to download. So everything's done automatically. You just tell it what to do. So what I'll do, that's a full-scale image. I'm going to shrink it down a bit, and we're going to adjust the settings to try to get a better image. And there you can see many stars. This is actually a rather poor image due to the moon being out there. It's just too much light. There are ways to adjust it to make it look better, but truthfully, it's you wouldn't be doing this kind of work with a full moon out there. You'd wait till another night. So that's basically how you get an image. Now this is just one image. This particular one was 2 minutes long. To get a good picture, you have to take several dozen or even 100 of these images and further process them. We'll have to show you that another time because it's rather involved. But just by looking at this initial one, it comes out monochrome. There's a way to convert it to color. We'll show that in another video. But that's basically what's going on, and a very rough way of how we take pictures in the observatory.